Last year, we studied something called relations. And a relation is just simply some relationship between two variables. So it could be a person's age and their height. It could be the time elapsed and kilometers driven. Okay? All sorts of relationships exist in real life, and we can analyze them mathematically. Then we studied a certain type of relation, which we called a function. Which every set of ordered pairs, every x value has only one corresponding y value. Do you guys remember how to tell whether something's a function or not? We used certain words. Something never, something never repeats. That first word, something never repeats. X values, or we learned this word last year, domain. Never repeats. That was sort of the way that we talked about how we can tell whether a relation was a function or not. We looked at all the x values, and if we saw more than one of the same one, it's not a function. If they were all different, it is a function. Okay? And there were all sorts of ways that we could show relations and functions. We could do a set of ordered pairs. You could have described them in words. If you remember, we did that arrow diagram with the two ovals and the arrows between them. We did graphs. We did equations. Okay? We did tables. All sorts of different ways to describe functions. Okay? Last year as well, we focused on graphing and finding equations of, linear functions, not equations, linear functions. What's a linear function? Well, it's a function that when you graph it, it's a line. Okay? And we did a lot on lines last year, how to find the slope of lines, how to find the intercepts of lines on a coordinate grid, how to graph them using different methods, the slope-intercept, the intercepts method, or table of values. We talked about if you're given a graph or some information about the line, you were able to find the equation. Okay, so we studied a lot on linear functions last year, or linear relations. And they basically are functions whose graphs can be written in the form y equals mx plus b. There's a y and an x. It's an equation with a y and an x in it. But then we learned fancy notation instead of y to call it a function. These two mean the same thing. F of x means the same as y. It's just that this is a relation, this is a function, because it's, and therefore it has the fancy notation. Okay. Okay, this year we're going to focus on a new type of function, which has a different type of graph, and we're going to analyze that, much like we did with lines last year. And we're going to see how we can use them in actual situations to solve problems. And these things are called quadratic functions. How can you tell if a function is quadratic? In the equation, it contains an x squared. Last year when we did lines, it was just x, y, and x, or f of x and x. This year it's going to be y and x squared, or f of x and x squared. So examples would be like y equals x squared. F of x equals x squared plus 5. We can put numbers around it. Y equals negative 2 x minus 1 all squared. If it's got a squared in it, it's quadratic. And if it's quadratic, when we graph it, it's going to take a certain shape that we call a parabola. Let's look at the most basic quadratic function. What's the most basic quadratic function? This one. F of x equals x squared. Or y equals x squared. They mean the same thing. F of x just means it's also a function. So just that y equals x squared. Nothing in front of the x squared, no parentheses, nothing after the x squareds, just x squared. What does that look like on a graph? Well, let's plot some points. And I'm going to use these ones. I'm going to make x is negative 2, x is negative 1, x is 0, x is 1, and x is 2. And then I'm going to figure out the corresponding y's. And then I'll have 5 points. And I should be able to see what my graph looks like, what my parabola looks like. So if I plug negative 2 in here, what is negative 2 all squared? Negative 2 squared. 4. So that's a point. Negative 2, 4. What happens if I try negative 1? Notice I'm using the table of values method here. What is negative 1 squared? 1. So negative 1, comma 1 is another point. Kind of looking like a line, but we're going to see it change. If I plug 0 in, what's 0 squared? 0. Now we got a curve action happening. Question is, what's going to happen over here? If I plug positive 1 in, what's 1 squared? 1, so I get 1, 1. And if I plug 2 in, 2 squared, 4. That's enough to show me what the shape's going to look like. That, and it keeps going up forever on both sides, and it keeps pushing slowly to the left and right forever. So it's kind of like a combination between a U and a V shape. It's not a U because, you don't have to write this, these don't go straight up. They split off. They're slowly going up, but they're also slowly going right and left. It's not a V because it's curved. So it's kind of like a combination between the two. This is the most basic one. Okay? And this is our parabola. Just like we did with lines last year, we found different properties. some are the same with parabolas, but others are different. So like we were able to find the slope of lines. We were able to find the intercepts of lines. Things like that, different characteristics. What are the characteristics or properties of parabolas? Something called a vertex. The vertex is the point where the parabola bottoms out, or if it's upside down, where it tops out. So the vertex in this case would be here. Because that's where it bottoms out. So we would say the point on a parabola where it bottoms out, if it's a right side up UV shaped, or parabolas can also be upside down, or where it tops out. Instead of bottoms out, we'll often use this word, minimum. It's the lowest point of the parabola if it's right side up. If it's upside down, it's the highest point or the maximum. That's the word maximum. So in f of x equals x squared, the vertex is 0, 0. The vertex is always a point. We're going to find that if we get an equation where there's numbers in with the x squared, the vertex is going to change. It's going to move around. The next two words you should be familiar with, although you may not quite remember what they are. Lines have domain and ranges. Domains and ranges. So do parabolas. What's the domain? All the x values. All the x values of the parabola. And range is all the y values. Of the parabola. So in the one parabola we've done so far, the most basic one, f of x equals x squared. Do you remember how to write the domain and range? That's if it's a series of points. If it's any kind of curve or line, there were two types of notation that we did. Do you remember? One had infinity symbols. There's set notation, which uses inequality signs, and then there's interval. And we generally found that one a little bit easier to use. You don't have to know both. You only have to know one. Okay? So let's write the domain using interval notation because it's a curve. Remember, domain is all the x values. So on this graph, what's the x value of the point to the furthest left? Yeah, negative infinity, because not only does this go up, it goes to the left forever. So the point to the furthest left is going to be at infinity, so its x value is going to be negative infinity. What about the point to the furthest right, the x value? Positive infinity. So therefore, using parentheses, we would say negative infinity to positive infinity. If you're a set notation person, this is where you use the X, E, R. Okay? Again, I'm just showing you this. Unless you're comfortable using set notation, I would suggest you stick with interval. Because generally it's easier to, in general, it's easier to write. So X values are left to right. Range values, or Y values, are lowest to highest. Whoops. What's the y coordinate of the lowest point? 0. What's the y coordinate of the highest point? Infinity, because it goes up forever. So therefore, the range would go from 0 to infinity, always parentheses around the infinity or negative infinity symbols, and a bracket around the 0, because that means we're including 0 in the range. Okay. The maximum or minimum value represents the y coordinate of the point, or sorry, the y coordinate of the vertex. And that kind of makes sense to what we were talking about before when we talked about the vertex. Okay? If it's a right side up parabola, there's going to be a minimum. Because there's a point, the vertex bottoms out. So there's a minimum that it reaches. It doesn't go any lower than that minimum. If it's an upside down parabola, we don't talk about minimums, we say maximum, because there's a maximum point, the vertex, where the parabola tops out. So in f of x equals x squared, the most basic one, think of the graph on the previous page, is there a minimum or maximum? Does it bottom out or does it top out? It bottoms out, which means there's a minimum. And where is the minimum? At whatever the y coordinate of the vertex is. What's the y coordinate of the vertex? 0. So that's what we would say. Okay, this last one, the equation of the axis of symmetry. Does anybody know what a symmetry line does? Like, you don't have to write this, but if I say gave you a rectangle, and I asked you to draw a line of symmetry on this rectangle so that it does what to the figure? Splits it into two equal pieces. Excellent. That's a symmetry line, or a line of symmetry, because it splits it into two equal pieces. Is there another one that I could draw on this figure? I could draw it this way. Is there another way? Really? Are you thinking diagonally? If you're thinking diagonally, it doesn't split it into two mirror images of each other. They have to be mirror images of each other. Okay? A square, you could do it diagonally, but not a rectangle. Okay? So, knowing a line of symmetry, where would you draw one on this parabola to split it into two equal pieces, one a mirror image of the other? The y-axis, exactly. So this would be the line of symmetry. Okay? But I want to know the equation of that line. Do you remember how to find the equation of a vertical line? This may be a little difficult to remember. A vertical line always has the variable, it only has one of the variables, x and y. What do you notice about every point on this green line? Think of one or two or three points on this line. What's the same? X. X will always be 0. So therefore, the equation is x equals 0. We don't need y and x. There's no slope to this that we use. Okay? So to define it, so it's, and it'll always be vertical. A vertical line that divides the parabola into two equal sections that are mirror images of each other. Okay? You can to write the equation of the vertical line, the equation is always the x coordinate of the vertex. Just like the minimum or maximum is the y coordinate of the vertex, the equation of the axis of symmetry is the x coordinate of the vertex. So if you know the vertex, And if you know whether it opens up or down, you can find a whole bunch of other properties. So in f of x equals x squared, the equation, and I'm just going to just to EQ apostrophe n, of the axis of symmetry is x equals 0. Those are the main properties. And those are all the specific properties of the most basic one, y equals x squared, or f of x equals x squared. There may be numbers in the equation as well. Okay? There may be numbers in front of the x squared, after the x squared, inside parentheses with the x, and then squared. It takes a certain form, and don't worry about this right now, because we're going to talk about each piece later. But the vertex form is y or f of x, you can use either one, is equal to, well, we could have a number in front of the x squared that we're going to call a. We could have a number inside the x and then being squared, which we're going to call h, and it has to be in subtraction form. There could be a number at the end being added or subtracted. All of these do something to the parabola. They change it in some way. So we're going to talk about each one separately. What happens if there's a number after the x squared? What does it do to a parabola? What happens if there's a number in front of the x squared getting multiplied? What does it do? What happens if that number is negative? What happens if there's a number inside being added or subtracted to x and then squared? Each of those do different things. And we're going to talk about this one first. And then we'll talk about this one next and this one last. So we're going to kind of go right to left. So the vertex form, using these variables, tells you how the parabola changes. I'm going to leave it at that. I'm going to keep it simple. We'll go into more detail later. When you graph a parabola, I know the very first one we did, we used a table of values to help us. But when you graph one, you should be able to do it without a table of values. And this is what you do. Okay? Start with the vertex. Well, we know the vertex of x squared is 0, 0. Then what did we do from the vertex? We moved one across in each direction, and then one squared up. And what's one squared? 1. So we moved one across in each direction, one squared, which is 1, up. There's 2 more points. What were the other 2? From the vertex, we moved 2 across in each direction, and then 2 squared up. What's 2 squared? 4. So we moved 2 across and 4 up. And then we get the parabola. You don't have to do a table of values. Okay. I'm not going to do this entire thing today. I just want to talk about what happens if there's a number after. Okay. And actually, I've got a table here, but we're actually not going to use it. So I'm going to see if you guys can figure this out. Come on. Okay. Here's a graph of y equals x squared. Would you agree? Vertex is at 0, 0. Then we go 1 across, 1 up. And then we go from the vertex 2 across, 4 up. That's x squared. Here's what x squared minus 1 looks like. Here's what x squared plus 3 looks like. What if I asked you to graph x squared plus 1? Without doing, just looking at this, what would you do? Like here's x squared, here's x squared minus 1. Here's x squared plus 3. X squared plus 1 would be where? Everything moves up 1. So the vertex moves up 1, and then I would go 1, 1, 2, 4. So what does a number being added or subtracted do to a parabola? Moves it up or down. That's it. So going back to this example, lovely. Yeah, that's okay, don't cooperate. There we go. So we don't even have to do this. Bless you. Because what is this? It's y equals x squared, or f of x equals x squared, moved down 1. So here's how we could graph it. Where's the vertex of x squared? Where's the vertex of x squared? 0, 0. Where's the vertex of this one? 0, negative 1. That's where the vertex is. And you remember what I just said about how to graph them? From the vertex, go 1 across, 1 up, 2 across, 4 up. It's so much quicker than a table of values. And there it is. I was taught it using a table of values first, but I find actually this is better. All right. And so, yeah, if it was plus 3, then we'd take x squared and move it 3 up. If it was minus 10, we'd take x squared and move it 10 down. When you graph these things, always start with the vertex. And then you can get the other points on the parabola. Okay. Just to sort of review the properties. Let's see if we can get all these properties. So x squared minus 1, the one that we just did on the previous page. What's the vertex? 0, negative 1, or minus 1. What's the domain, left to right? Yeah. You know what? No matter what the parabola looks like, whether it's right side up or upside down, the domain is always this. Never changes. Okay? It's the range that changes, depending if there's numbers. What would be the range of this one? -1 to infinity, with a bracket around the -1. The equation of the axis of symmetry. Remember what I said? X vertex. It's the same as the X vertex. So you've got to write X equals, because it's a line, -1. What's the X coordinate of the vertex? It's still 0. It didn't move. The equation of the axis of symmetry, if I move up or down, will still stay the same. There is a minimum value because it bottoms out. Where? Y equals -1. Remember, put those X's and Y's in. Don't just write 0 and -1. Okay? So, if we compare those two graphs, f of x equals x squared, f of x equals x squared minus 1, size and shape of the parabola are the same, except f of x equals x squared minus 1 moved down 1 unit. So what happens when there's a number at the end of the equation being added or subtracted? It moves it up or down. If that number, k, is positive, that's what k, that means positive, then we shift it up, whatever the value of k is. So we shift it up k units. Or sorry, k units up. If it's a subtraction, or k is 0, or k is negative, we shift it down. Now, you may see some weird looking notation around the k here. Anybody know what that is? What that represents? I don't know if you took it in science or not. Okay, it's called absolute value. Absolute value is really easy. To find the absolute value of any number, it's its distance from 0. What's the absolute value of 5? What's the absolute value of -5? 5. What's the absolute value of 10? What's the absolute value of -10? 10. Do you notice it's just the same number, but it's always positive? Okay. So, and that makes sense, because if it was x squared minus 1, we don't shift it down -1. That doesn't make sense. We shift it down 1. That's why we've got to put this in here. But don't worry about that too much. I mean, be more concerned about how to graph it and how to state the properties. The vertex of the parabola will always be 0 for the x, and whatever the value of k is for the y. That will always be the vertex. So if it's -1, the vertex is 0, -1. If it's +5, the vertex is 0, 5. The equation of the axis of symmetry will never change. It'll always be x equals 0. And I'm going to stop there because that's quite a bit. Yes?